Hi, my name is Ron Vogel. Thanks for the introduction. I'm a solutions architect at Genware Computer Systems. And today we're going to be speaking about TIBCO Data Science. So today's focus, as I mentioned, on TIBCO Data Science or TDS. The agenda today is digital disruption and challenges, data science solution and benefits, and finally, I'll be speaking a little bit about innovation at the edge. So digital disruption abound. Essentially, change is accelerating, and this notion of the algorithm economy is emerging. So the data that we see every day and we capture, regardless of industry, is inherently dumb. It doesn't really do anything unless you know how to use it. So the important component of being able to analyze and make sense of the data is to formulate an algorithm. So an algorithm is a set of rules, essentially, which then defines the actions you can take on the data. So a little bit about AI, ML, and deep learning. So artificial intelligence is a general approach to the simulation of cognitive processes. Data science and machine learning is using algorithms, which we just discussed, to parse the data, capture knowledge, and make some sort of a prediction using possibly building a predictive model and then deploying that model to make business decisions based on the outputs. And then finally, some of you may have heard this notion of deep learning, which is a subset of machine learning, and it's generally used for images, videos, and voice analysis or analytics. So data science defined. What is data science? There are four major components to it. So descriptive, what happened; diagnostic, why did it happen; predictive, what will happen; and then prescriptive, what should I do based on the predictions. So it's all about determining first what did it happen, what happened, and then figuring out, using data science to develop, as I mentioned, models so that you can make predictions and then have those models learn based on incoming data. So having those models learn and then make once you have your prediction, the prescriptive component is the actions that you should take based on those predictions and based on the models. So what are we talking about? Data science is used across lots of different industries. You can see some of those here. Things like fraud, whether we're looking at finance or banking; disease detection in healthcare. You have cybersecurity, quality analysis, potentially in manufacturing. Then you've got product recommendations, so marketing, digital media, social platforms, things of that nature. And then you have your traditional forecasts based on your demand forecasts, possibly based on sales in a sales organization. And then you can see their logistics. So air travel, trains, being able to predict or forecast the number of flights, or for logistics, optimizing routes potentially for deliveries and so forth. So lots of different areas where data science is used. So some of the terminology, this slide just shows some of the things you may have heard surrounding data science. So you've got programming languages. Modern programming languages like R and Python are widely used and tightly integrated with TIBCO Data Science. You've got a interactive coding interface found in Jupyter Notebooks, where data scientists are able to use that to write R and Python. Then you've got the big database platforms like Hadoop, Spark, and Hive, to name a few. Open source libraries for algorithms like Spark, MLib, and H2O. And then you have finally the things like Amazon SageMaker, Google Cloud Machine Learning, and Azure Machine Learning are data science platforms as well that help the scientists build, train, and deploy their algorithms to scale. So how does data science work? This essentially defines it in 3 steps. You have input data, where you've got both structured and unstructured data. So structured data, things like your traditional databases, could be stored at rest, could be sensor readings coming in as a streaming data source as another example. Then you've got your unstructured data, so text, images, social media, potentially through accessing that data through APIs or web services. And then following that, your data prep, so you're potentially performing some ETL or doing some data integration with something like TIBCO Data Virtualization, for example, to integrate that data and prepare that data. And then following that, you have a machine learning process where algorithms and models are defined. And then on to model deployment, scoring, and management. So using Team Studio to manage that, the model deployment and scoring process. And then finally, your outputs. So those outputs are where that prescriptive component comes from. So you're using the outputs, which are usually predictions, and you're then that enables you to take action and use those. Again, use those predictions to take action and apply those to your business systems and business processes. So what are the top challenges with data science? We see a long list of challenges here. At the very top, you see dirty data, which is a major challenge, lack of data science talent, and then lack of management and financial support in support of data science. So the top three AI and ML challenges fall into these three buckets: organizational, so the lack of focus and alignment between your data science teams, your business teams, and finally IT. Process challenges, so coordinating and developing and deployment and maintainability of the models. So all of that, there are challenges found there. And then finally, technology. So we saw the top challenge was dirty data. So data challenges, incompatible systems, and then infrastructure challenges. We have data and algorithms. We can draw insights from the data from multiple integrated systems. We can make smart decisions in a timely manner, and we can transform into a business that can compete and survive in the current day and age. So what are the required capabilities for effective data science? We spoke a little bit about inaccessible data or dirty data. So the key capabilities we see here, as I mentioned, is TIBCO Data Virtualization. So we see here, this is the Data Virtualization Studio where you can take advantage of integrating and accessing data that may not easily be able to be accessed. Then you can visually manipulate, perform some ETL to clean that dirty data, transform it, and then make it readily available for analytics or for data science downstream. So again, dirty data, we see while we can use data virtualization to do some of that, we can also use something like TIBCO Spotfire, which is TIBCO's data visualization platform. And we can use Spotfire to either use its visual wrangling capabilities and AI automatically suggesting transformations for us. We can use it to remove outliers and clean the data. And then we can use the automation capabilities to do data health checks, fill in missing values, and so forth. And then finally, once that data is cleaned, we can then export that data or access it directly from TIBCO Data Science if we need to. So limited talent and expertise. So this is we see here, this is TIBCO Spotfire Data Science Team Studio, which we will we'll take a look at that in the demo. So the key capabilities here are, again, automated recommendations to make sense of the complexity, the ability to collaborate as a team. So the Team Studio uses a portal, a web-based portal for access. So it's going to allow the entire team, not just a few data scientists, but many data scientists across the team. It's going to provide them access, and it's going to provide the notion of the citizen data scientist. So it's going to allow the entire team access to be able to do some data science activities, and not just a few. And then finally, creating reusable parameterized templates. So in Team Studio, you can then save your template and then run that so that you can scale out your machine learning platform. So results not being used. This is another challenge. So often we see the data scientists create models using open source tools, and those models are never operationalized because they're potentially siloed. So they're sitting on a data scientist's machine, and it's not easily deployed to scale. So the results in Team Studio and TIBCO Data Science allow you to take those deployments, operationalize them, and embed them into business processes, and also allow you to deploy them and allow others to assist with model monitoring, to assist with retraining of those models, governance, and essentially ensure the successful handoff of the outputs of those models downstream to business processes and other systems that can then take advantage and make, as we mentioned, business decisions based on those outputs and those predictions. So TIBCO Data Science: collaborate, operationalize, and scale your machine learning across your organization. So this shows pretty much end-to-end the skills required to realize the value. And it shows a number of different areas in the TIBCO technology lifecycle, essentially, where you've got data engineers using something like EBX to manage master data. You've got data virtualization for the integration and the preparation of your data. You've got data science sitting in the middle, which I mentioned now can be used by not just a few data scientists or a few data science authors, but now can be used across business analysts, citizen data scientists, to assist with applying some of the data science models and so forth, again, to other business processes and systems. You've got embedded analytics, and then you've got enterprise reporting using something like TIBCO Spotfire to report on and visualize the data and outputs from your data science. So it's not simply just data scientists. You can see the entire team is involved in operationalizing your data science. So again, it's a team sport. You can see here the key capabilities for each of the data science roles. So you have data scientists who would create the templates and collaborate on projects. You've got the citizen data scientists who, again, may manage parameters to be run from TIBCO Spotfire or other BI applications, and maybe using the outputs of the data science models for other applications. The developers are perhaps automatically deploying those pipelines to the edge, to TIBCO Streaming or Project Flogo. APIs can also be used in other business systems and so forth. And then you have data engineers reusing the data and data prep pipelines across different environments. And then finally, business experts and leaders. So making business decisions based on the outputs of those models. So supporting the end-to-end machine learning lifecycle. Again, we have data access and prep. We have modeling potentially using Notebook Server or using the Team Studio workspace. Operations and deployment. So within that workspace, you're managing that model and applying parameters for relearning and retraining of the model. And then finally, using visual analytics, using TIBCO Spotfire, using batch automation or real-time event processing. You're then taking the outputs of those models and then based on the predictions, you're making some decisions downstream. So to supply chain, to engineering, to customer analytics, all of those business systems can then take advantage of the outputs. So this is showing Team Studio, which we'll show in the demo as well. It's a leading platform for business exploration, prototyping, and production refinement. So we see here it's a cloud-friendly user interface for data prep and machine learning. You have the ability to use Jupyter Notebooks for authoring, which is also point and click visual interface. You have a social collaboration, Slack-like environment for collaborating across the citizen data scientists and also for project management. And then finally, all the computations occur in cluster or in database. Statistica is a rich desktop environment which is typically used by your data scientist for building the models. You're going to be combining your data sources for in-memory computations, creating reusable templates and workflows that then the citizen data scientist can take advantage of. So it's a robust, mature model management and governance solution. And then this speaks a little bit about the platform. So we talked a little bit about the data science authors using Visual Studio, using the workflows, the notebook server in Team Studio, using Statistica, and so forth to build the models. And then the operations side of data science, the citizen data scientists have access to Team Studio for model management, for collaboration, for applying governance and rules, and then finally for automating, potentially automating the outputs of those models and applying them downstream. If you would like to learn more about how TIBCO Data Science can help operationalize data science and advanced analytics for your organization, please feel free to contact me or one of my associates at the email shown here. Thank you.